Welcome back to iptables Mastery, Lesson 8, and this one's about keeping you out of the worst kind of trouble. Every rule you've crafted lives in kernel RAM, which means one reboot wipes the slate clean, and one fat-fingered rule from a remote SSH session can lock you out of the box entirely. So today, we're treating your firewall config like production code, saved, restored atomically, and protected by a dead man rollback for when you're editing from the other side of the planet. Here's the whole lesson on one page, 4 moves. First, iptables-save dumps your live rule set to plain text you can commit to Git. Second, iptables-restore loads it back atomically. Every rule lands, or none of them do. Third, the persistent packages make that file auto-load on boot, so reboots stop hurting. And fourth, the dead man rollback, a background timer that wipes your changes if you get locked out and can't cancel it. Save, restore, persist, protect. Let's break each one down. Start with save, because it's the foundation. Run iptables-save, and you get exactly this. A plain text dump organized by table. Each table opens with an asterisk. The chain policies and counters sit at the top with colons. Then your rules follow as straight. Append lines. Notice there's no word iptables anywhere. Strip that off, group by table, and you've got the format. It's diffable in Git, reviewable in a pull request, and replayable on any box. That format unlocks the whole workflow, and it breaks down into 3 beats: save, edit, restore. Save dumps the live rule set to a file. That's your backup and your starting point. Edit happens in a text editor, completely offline from the kernel, so mistakes cost you nothing until you're ready. Then, restore loads the file atomically. Every rule lands, or none of them do. No half-applied states, no firewall stuck halfway between 2 configs. Now here's the habit that separates confident operators from terrified ones, the dead man rollback. Picture 2 timelines. Without rollback, you push a bad rule, SSH dies, and you're locked out until someone walks to a console. And worse, that bad config survives a reboot. With rollback, you save your current rules, schedule a restore in 2 minutes with a backgrounded sleep, then load your new rules. If they lock you out, you just wait. The timer fires, the old rules come back, and you reconnect. 2 minutes of patience instead of a flight to the data center. Once you trust your rules, you want them to survive a reboot, and every distro has its own thin wrapper around iptables-restore to do exactly that. On Debian and Ubuntu, install iptables-persistent and run netfilter-persistent save. It writes to SSH'd iptables rules v4. On Rail, CentOS, and Rocky, it's iptables-services, saving to etc. sysconfig iptables, but disable firewalled first, or you'll fight 2 firewalls. On Arch and Manjaro, nothing to install. Just pipe iptables, save into etc. iptables, iptables, rules, and the built-in system unit handles the rest. Now here's where it gets interesting. The moment your rules live in a text file, they're code, and code belongs in Git. Run git init inside etc. iptables, commit your baseline, and from then on, every change leaves a trail. Who touched it, when, and why. Diff before you deploy, catch bad rules in review, and when Tuesday's edit breaks Wednesday's deploy, Git checkout head 3 is your time machine back to last week's firewall. And version control only works because of one deeper truth: atomicity. When you run iptables-restore, the kernel doesn't apply rules line by line. It swaps the entire rule set in a single transaction, or it rejects the whole file. A typo on line 47? Nothing applies. You're never half-configured, never half-broken. That's principle 1. Principle 2. It's plain text, so every tool you already own, grep, diff, sed, git, just works. And principle 3. Rollback isn't paranoia, it's an acknowledgement that editing a firewall over SSH is genuinely dangerous. The fix isn't being more careful, the fix is a safety net. So here's your safety net. printed on one page. Left column, the save and restore primitives. Dump to file, scope to a single table, dry run with T before you commit. Middle column, distro-specific persistence, because Debian and R shell disagree about everything, including which package survives a reboot. Right column is the one to tattoo on your forearm. Backup, schedule a rollback in a backgrounded subshell, apply your changes, verify you can still reconnect, and only then kill the timer. If step 4 fails, you do nothing. In 2 minutes, the kernel restores itself. Knowing the pattern isn't enough, you need it in your fingers. So 3 drills all inside a VM where a mistake costs you nothing. First, the basic loop: dump, edit, restore, verify. Second, the one that matters most: deliberately lock yourself out, then watch the scheduled rollback save you 60 seconds later. Third, install iptables-persistent and reboot to prove your rules actually come back. Do these until the dead man timer is reflex, not a checklist item. Once the drills are muscle memory, know the failure modes that actually take systems down. 5 of them, all preventable. You edit rules and never save, reboot, gone. You install iptables-persistent, but trust a stale file from install day. You change a chain policy without a rollback timer and lock yourself out. Your rules.v4 has a typo, restore exits non-zero, and your script never checks. Or you mix manual edits with the on-disk file until they drift apart and a reload silently rewrites your firewall. Each one has a one-line fix. Learn them before you need them. That's lesson 8. You can dump rules to text, restore them atomically, survive a reboot, and back out of a bad edit before it strands you. Treat your firewall like production code, saved, versioned, and always with a rollback timer when you're working remote. Next up, lesson 9, logging and debugging. We'll wire up the log target, read the kernel ring buffer, and answer the question every operator eventually asks: why isn't my rule firing? See you there.